Hiram Maxim, a British subject of American origin, was a gifted inventor. He improved the electric light bulb before Thomas Edison and built an airplane before the Wright brothers. Yet today few remember those achievements. His name became synonymous with something else. He went down in history as the inventor of the deadliest weapon of the late 19th and early 20th centuries. In the spring of 1887, a distinguished visitor arrived at the Steinfeld Proving Ground near Vienna, where the Austrian army was testing new rapid-fire weapons. Emperor Franz Joseph had come in person to see the gun that was being predicted a great future. With clear approval, he watched two soldiers operate a gleaming, 5-barreled rifled machine gun made by the Nordenfeldt Company. One fed the cartridges, while the other, carefully turning a crank, delivered 180 rounds per minute. The final participant in the trials was a heavy-set, bearded American, an inventor and sales agent representing the sole product of a little-known British firm, a squat, short, thick, rather ugly firing device. Hiram Stevens Maxim, dressed in a proper morning coat and top hat, perched on a tiny seat bolted to the rear support of an awkward tripod and grasped the handles of a black metal box from which protruded a single barrel encased in a water-cooling jacket. At the signal, he opened fire. In 30 seconds, 330 bullets punched the Emperor's initials, F.J., into a target set 100 meters away. The smoke was still curling upward and the last cartridge case had barely hit the ground when Maxim rose and bowed to His Imperial Majesty. A stunned silence followed. The Emperor and his entourage were at a loss for words. Hiram Stevens Maxim was born on February 5, 1840, near Sangerville, Maine. He received less than 5 years of formal schooling. From his father, a skilled carpenter and self-taught mechanic, he learned to work with wood and metal. Even as a child, Maxim showed inventive talent. He designed a chronometer, a spoked wheel for a bicycle, and eventually a mousetrap. Later he took on almost any job: carpenter, carriage maker, painter, contractor, professional wrestler, and bartender. He was well suited to the latter. He did not drink himself and was strong enough to throw unruly customers out of the bar. He did not serve in the Civil War. He was exempted after 2 of his brothers were killed in service. In 1864 Maxim settled in Boston. He married there and, to support his family, went to work for his uncle, Levi Stevens. Maxim solved technical problems quickly but lacked the patience to distinguish trivial details from essential ones. He often reinvented the wheel and typically ignored questions of production and marketing. Stevens manufactured automatic gas generators for domestic lighting. Maxim was hired as a draftsman but immediately devised improvements to the generator. Hardly had Stevens retooled his factory to produce the new version when his nephew proposed further modifications and insisted the production line be rebuilt again. When this happened repeatedly, he was dismissed. Still, Maxim easily found work, first in Boston, then in New York. Gas and steam were his favorite elements. He adored steam engines. He designed and built pressure gauges, pipes, valves, engines, vacuum pumps, carburetors, flywheels, regulators, and burners. With his own hands he built a 23-foot steam launch called Flirt so he could cruise the Hudson River with his son. In 1873 Maxim went into business for himself, founding the Maxim Gas Company after persuading A.T. Stewart, owner of a chain of department stores and then the wealthiest man in America, to back him. He installed gas lighting in a Manhattan post office, a resort in Saratoga, and a hotel in Atlanta. He also designed a powerful gas searchlight soon mounted on locomotives across the East Coast railroads. Yet Maxim understood that the era of gas lighting was ending. Beginning in 1876, he turned to electricity. His sketches and models impressed New York financiers so much that in June 1878 they formed the United States Electric Lighting Company to develop his inventions. The company aimed to capture part of the arc lighting market. But while arc lamps worked reasonably well for street lighting, they were unsuitable indoors. The carbon electrodes posed a danger, required frequent replacement, and offered no practical brightness control. Maxim devoted most of his time to the incandescent lamp. A race was underway among gifted inventors to perfect a bulb capable of replacing gas jets in homes and offices. Competition intensified in 1877 when Thomas Edison entered the field. Edison began filing his first incandescent lamp patent on October 5, 1878. Although Maxim submitted his application one day earlier, the court ruled in Edison's favor. Maxim came to hate Edison. Edison in turn called Maxim a pirate and, after the outbreak of World War I, labeled him a merchant of death. From the 1870s onward, Maxim's chief aim was to outdo Edison. In some respects he achieved notable success. After experimenting with platinum and other filament materials, he settled on carbon. Recognizing that weak spots in the filament would quickly burn out, Maxim devised a method to make filaments more uniform by depositing carbon from hydrocarbon vapors. Edison was forced to copy this already patented process, which gave Maxim a certain satisfaction. Maxim also patented a regulator that equalized voltage across all lamps in a network. Although he could not achieve a perfect vacuum inside the bulb, his lamps worked. In the fall of 1880, 6 months after the Edison Electric Light Company installed the first commercial electric lighting system aboard the steamship Columbia, Maxim's company electrified the first building in the United States, the Equitable Life Assurance Company building in New York. It soon became clear, however, that Maxim was losing the electric war. Unlike Maxim, Edison grasped the theoretical relationships among voltage, resistance, current, and energy loss in incandescent systems. He worked not only on the bulb but on the entire infrastructure, lamp, generator, and distribution network, needed to deliver electricity reliably. Meanwhile, the board of Maxim's company appointed Charles Flint as manager. Flint quickly realized that U.S. electric lighting lacked a comprehensive lighting system, that its patent position was weak, and that the chief engineer was driven largely by personal revenge. After purchasing the Weston Company, which developed electric generators, in 1880, Flint sent Maxim on an extended trip to Europe, ostensibly to acquire foreign patents that might circumvent Edison's protections. In reality, they were simply removing him. In exchange for his stake in the company, Maxim received fees and a respectable salary and was appointed head of a subsidiary, Maxim Weston, in London. Insulted but undeterred, he chose to see this exile as a new opportunity. In 1881 Maxim remarried and moved to Europe, never returning to the United States. At the Paris World's Fair he enjoyed resounding success. An entire issue of the exhibition journal was devoted to his electrical achievements. Both he and Edison were awarded the Legion of Honor. Soon Maxim's attention shifted again. A casual remark made by an American acquaintance in Vienna lodged in his mind: forget chemistry and electricity. If you want to make a fortune, invent something that helps these Europeans cut each other's throats more efficiently. It seemed true. While American investors were obsessed with electricity, European financiers were captivated by armaments. Instead of reorganizing the Maxim Weston plant in London, Maxim rented workshops in Hatton Garden and set about inventing automatic weapons. The energy with which he pursued the new project may have sprung from a vague desire for revenge after his recent defeat. The drawings were completed in the fall of 1882, and 13 months later the first working model appeared. Legend claims the idea occurred to Maxim when, as a boy hunting bear, he realized that the recoil of a heavy rifle was wasted energy. In fact, the machine gun's mechanism more closely resembled a two-stroke steam engine, the kind Maxim had reworked many times in his life. Powder gases played the role of steam, the trigger acted as a valve drive, the bolt functioned like a piston. Upon recoil, the bolt moved backward, ejecting the spent cartridge and feeding the next round. Any recoil energy not used in this motion was stored in a spring, which then drove the bolt forward, locking the breech and firing the inserted cartridge. Despite its apparent simplicity, the Maxim gun contained 280 interchangeable parts, most requiring manufacturing tolerances uncommon in England at the time. Maxim telegraphed his brother Hudson in America, urging him to hire several American machinists and send them to Europe on the next steamer. Together with 5 partners, including 2 Vickers brothers, Maxim founded the Maxim Gun Company with capital of £50,000. Hudson set up an assembly line in Crayford, Kent. Having learned from his patent battles with Edison, Maxim secured numerous British and foreign patents between 1883 and 1895, covering every possible variation of recoil-operated reloading. He rifled the barrel, redesigned the mechanism for the .303 caliber, added water cooling, reduced weight with nickel steel, and invented a universal mounting system. The manual claimed the gun could be mounted on anything from boats to bicycles. That section later had to be revised after a foolish lieutenant strapped one to the back of a mule and set it to automatic fire. To further improve the weapon, the brothers experimented with smokeless powder. Black powder produced revealing clouds of smoke and fouled the barrel. It also burned too slowly to achieve the desired rate of fire. By soaking cotton in nitroglycerin and using castor oil as a binder, they twisted thin hollow tubes which, when cut, became air-filled and burned more rapidly. This was an early form of true cordite. Compared with rival designs, the American Gatling gun, 1862, the French mitrailleuse, 1867, and the Anglo-Swedish Nordenfelt, 1877, the Maxim gun had major advantages. Those weapons were hand-cranked and gravity-fed, their relatively low rate of fire did not justify their weight or the crew required. They frequently jammed if the operator cranked too quickly or if a cartridge failed to seat properly. Damp or old ammunition could ignite late, sometimes exploding just as the chamber opened for a new round. All were prone to overheating and required pauses for cooling. In Maxim's design, a belt fed smoothly into the breech as long as the gunner held the trigger. To change belts, one simply inserted the leading end of a new belt. Because a fresh round entered the mechanism only after the previous one fired, even a delayed shot could not jam it. Water circulating in the jacket provided continuous cooling without excessive weight. The gun with its mount weighed 60 pounds, 27 kilograms. This weapon established the fundamental principles of automatic firearms still in use today. In the spring of 1885, Maxim demonstrated his gun at the Inventions exhibition in South Kensington, attracting distinguished visitors. The gun looked small and harmless. Lord Wolseley, head of the War Office, even asked whether Maxim could build something larger. Maxim replied that a bigger gun would not kill people any faster. Nevertheless, he built a larger version, something between a cannon and a machine gun, firing 37mm explosive shells almost as rapidly as the standard gun. The British government did not purchase the half-cannon, and Maxim sold it to the Boers in South Africa, where it earned the nickname Pom-Pom. Observers were astonished not only by its effectiveness but by its cost. Watching it consume belts of shells, the King of Denmark remarked, "This gun would bankrupt my kingdom in 2 hours." Despite its technical superiority, the Maxim gun did not immediately secure lucrative government contracts. The U.S. Army declined, citing its excessive rate of fire and the logistical burden of supplying ammunition. Meanwhile, Basil Zaharoff, representing the rival Nordenfeldt Company, used dubious tactics to win contracts, once even plying a gunner with alcohol before a demonstration in La Spezia so he could not operate the weapon. Sabotage and defective ammunition were not uncommon. Realizing he lacked the skills of a ruthless businessman, Maxim merged with Nordenfeldt in 1888. The partnership lasted until 1896, when Vickers acquired Maxim Nordenfeldt. Zaharoff, now working for Vickers, helped make the Maxim gun standard in arsenals worldwide. After the merger, Maxim returned to inventing an aerial torpedo, electric artillery aiming systems, delayed fuses. The company suffered financial losses, and in 1896 Vickers bought out Maxim's share. By acquiring his company, Vickers gained rights not only to the machine gun but also to one of the world's earliest airplanes. Naturalized as a British citizen in 1900, Maxim was knighted by Queen Victoria in recognition of his contributions to British arms in Sudan, 1896 to 1898. And at the Battle of Omdurman, 1898. In the late 1880s the British government commissioned Maxim to build an airplane. He conducted classic experiments measuring propeller thrust with his own dynamometers and tachometers. By 1891 he had constructed a vast hangar in Baldwin's Park, Kent, with a half-kilometer rail track for acceleration and elevated guide rails to limit lift. His aircraft used 2 steam engines delivering remarkable power-to-weight ratios. On July 31, 1894, during final trials, the machine lifted off with Maxim and 2 passengers aboard, flying about 200 meters, held down only by safety rails. A jammed wheel caused a crash that destroyed both rails and aircraft. Maxim never rebuilt it. In 1910, at Vickers' insistence, he built another airplane with an internal combustion engine, but it failed to take off. Historians still debate the significance of his aviation achievements. Critics argue he focused on thrust and lift while neglecting stability and control. Yet his machine did leave the ground, at least 9 years before the Wright brothers' flyer. In 1911 his partners, disappointed with his aviation results, forced his retirement and even removed his name from the company title. When Vickers later built a successful aircraft, an ancestor of the famous Spitfire that would win the Battle of Britain, it was armed with a Maxim machine gun. After retiring, Sir Hiram Maxim returned to steam engines. He invented a primitive echolocating device powered by steam and also designed a steam inhaler that genuinely helped thousands of bronchitis sufferers, including himself. Yet it was the machine gun, his killing machine, as he called it, that brought him fame and fortune. When Hiram Maxim died in 1916, only a few British and American newspapers published obituaries. Their pages were filled instead with reports of millions of other deaths, most caused by the Maxim gun.